Okay. So sine 2 theta equal to 2. So part A will be solved for all solutions. Part B will be solved for one period. In other words, from 0 to 2 pi. Almost the exact same question here. I think yours is a cosine, it's the only difference, all right? So if you solve for all solutions first, it'll be a little easier to part B. So basically what I want you to do is pretend it's just a regular sine and figure out, okay, well, where is sine 1/2? And let's do radians this time. All right, so if I do sine inverse of both sides, this is the actual work. I'm going to get 2 theta equal to sine of 1/2 be what? Pi over 3, right? Divide by 2 on both sides. I'm going to get pi equal to. It'll be like my first theta. Theta 1 will be pi. Well, actually, I'm sorry. Before we do that, that'll be the first set. The second set will be pi minus 5/3 for the other solution, right? Pi minus 5/3, that's going to be 2 pi/3, right? Okay, so we have two solutions for part A. Theta 1 will equal pi over 3 plus 2 pi k. The second one will equal 2 pi over 3 plus 2 pi k. Yes?
How come they're the same part of this?
That's because it's actually a double angle. So if it was a normal, like I think on what's today? On Wednesday, we would just go straight to here and be done, right? But we have to deal with that too because of this. Everything is the same except you have that extra 2. So now the new step would be divide everything by 2 because we need theta, not 2 theta. So if I divide everything by 2, the first solution set will be pi over 6 plus pi k. Right? Divide this by 2, you get a pi 6. Divide that by 2, get a pi instead of a 2 pi. Same thing here. Divide by 2, divide by 2. That'll give us the second set. So that'll be pi over 3 plus pi k. So quickly pi. Okay. So these are the solutions. These are all solutions for part A. Okay, that makes sense because the next part is the hard part.
That's pi over 6, right?
Yes, 6 and pi third. So I'm going to use these to help me find the solutions in one period. Let me show you a visual as to what we're doing. Okay. So the original, sine x, right? If I put y equal to 1/2, we can find all the angles that give that to me. So I know the solution on the circle are going to be pi over 6, 5 pi over 6, etc. Though, real quick, let me show you the beginning of the interval and the ending, right? So between the green and the purple line, that is one period. So the sign goes one time and then it repeats. So every 2 pi, the sine function repeats over and over again. That's why I tell you to find the solution in one period, because if I don't tell you restriction, you'll find infinite solutions, which is why I have that k pi attached, 2 pi k. That takes into account the repetitive nature of sine. Okay, so if you have double angle though, you can see how the black one repeats itself multiple times, actually twice as much as the red one. So that means it's going to have more solutions within that same period. Does that make sense? So instead of just having 2, you're going to have 4. Second, let's pull the circle for later. Oh, I made a small mistake. Sorry. Check this out. It should have been pi 6. I put pi thirds for sine. Sorry about that. Let's go back to the notes. This should have been 6. This should have been 'So pi minus pi 6, that would be 5 pi 6. Dang it. All right, there we go. I thought it looked off. So now when we divide by 2, everything will be the same except this should have been a pi 12 right there. This would be 5 pi 12s. Okay. Oh, if you subtract pi minus pi over 6, you get a common denominator of 6 pi over 6. You're going to get 5. That's where this came from. You guys cool on page 1? All right, so I'm going to copy these to the next page to help us find part B. So pi 12 over pi plus pi k, theta 1. You guys cool on the last page? It's no rush. If you missed something, let me know. So what you got to do, so remember, I told you there's 4 solutions, right? So what you do is let k range from 0 and 1, but not 2. Because once you hit 2, so if you have sine 2 theta, let k go 0, 1. If you have 3 theta inside a triple angle, you do k 0, 1, 2. Okay. So I'm going to do 0. So now I have two solutions. Theta 1 will be pi over 12 plus pi times 0. Theta 2 will be 5 pi 12 plus pi times 0. So my first solution, or first two, are these guys. Okay. Now let k, the next set, equal to 1. So theta 3 will be pi 12ths plus a single pi. Theta 4 will be 5 pi 12ths plus a single pi. So add that together. What's pi theta 3 going to be? Yeah, 13 pi over 12. This guy will be 5 pi 12 plus 12 pi over 12. Okay. So the next answer will be 17 pi 12. We got 4 solutions. Does that make sense? So in your exam question, the one that has 3 theta, you're going to have 6 solutions. Okay. So you're going to follow the same process. You're going to let k equal 0, 1, and then 2. You'll stop. Now, if you let k be 3, you're going to notice that's outside the one period. Because if you let k be 2 here, it'd be 2 pi plus something which is bigger than 2 pi. So that's outside the period. That's why we choose 0 and 1. Okay. So just rule of thumb, whatever's on the theta, let k be 1 less than that. 0, 1, whatever. N minus 1. Okay. That's pretty much it. That's all I wanted to talk about. Make sure you have an example about that. You guys have any questions on homework, or don't ask me exam questions? Yeah.
Do you know how to get like the pi symbol and stuff in here? Like, because when I do, I don't know, pi over 12 plus pi, it just gives you the number. And I even go to the same tabs and I press 3 for radians instead of the other.
Yours might be older. Let me see.
Try.
It doesn't have a fraction button, I don't think, right? It doesn't do that either.
I lost it.
So there is a pi button, but as soon as you press enter, it goes to the rounding. So I mean, you could do calculations like this, but as soon as you press enter, it's going to be yeah, like it can take exact values, but it's going to give you approximate, which is fine, but it will not add like fractions for you like this. It'll only give you decimals. Let me see. Yeah. Try that guy. it'll add basic fractions for you, but not the stuff with pi. So if you want to treat these like basic numbers, for example, this would be the same as 1/12 plus a 1, right? That's the same thing if we ignore the pi. You could do that, 13 pi. That's one way around it, but it's the best I can do. Goodbye. No, I wouldn't buy it. Unless you like spending extra money, it's up to you. Okay, any other questions? Any problems in the homework that are struggling with, or, because I know they're due pretty soon. Got 2 of them due this weekend. Or I think one's on, was it Saturday? One's Monday. You looked at them yet? Like I thought about looking at it. That's right. I'm trying to give you crap because I'm a very bad procrastinator, so I get it. But also, what's the word? You need to learn how to manage it and be successful and procrastinate. Don't procrastinate and fail. That's not an option. You got to be able to do both. Or don't procrastinate. It's also an option too. Although I've been telling myself for years, but whatever. All right, guys. Well, if you want to stick around and do problems, you can. If not, you can head out and I'll upload these videos. It's up to you. We got nothing going on today, so I know. You want to say something? I don't remember. Did I post it? Did you see it? Okay. I'll do both today. Do that right now.
Wait a minute.